Hi, I'm Jay Beale. I'm CTO over at Guardians, here to talk about attacking Kubernetes at KringleCon, where I am freezing my tuchus off. I think it's because I keep reaching into the ice to get the freshest of the sushi. So this talk is all demo. It is tied to last year's story from the Holiday Hack Challenge, where the Tooth Fairy was the villain, and we're continuing by saying that she left a logic bomb behind running in a Kubernetes cluster. And if we don't deactivate that logic bomb, it would be bad, like Egon Spengler bad. So one of her developers, luckily, has found redemption and wants to help us out. And Kent's going to try to help us get the logic bomb's password before it causes bad things to happen. So what is Kent? What's Kent's starting point? He has complete administrative privilege in his namespace, a very common thing for organizations to do. But outside of his namespace, he has very little privilege. He's kind of got read-only, and he can only read some things. So this cluster is staged in GKE, Google's managed Kubernetes service, which creates nodes as virtual machine instances, GC instances, in a Google Cloud project. So Kent's got some ideas about how he might do things, but let's go straight into our demo. So if you like what we're doing, if you like what you're seeing here, if you're really interested, please come take a look at InGuardian's Kubernetes work in general, and especially our open source Paratis program. So with that said, I'm going to go right into the demo. So Kent is on the Kubernetes cluster. He's just doing a quick look at all the namespaces that are out there. There are a ton. He knows that the thing he's looking for is probably a secret that's in one of those namespaces, but he doesn't know which one, and he probably doesn't even have access to list the secrets. He made a list of namespaces. We can kind of see the one that he's got, Developer Kent. And Developer Kent, he can list secrets and get their contents and even create new ones. But outside of that, in the cluster at large, if you were to even go namespace by namespace, you can't list or read secrets and the other things. So he's going to start by just creating a quick pod in Kubernetes in the kind of one of the simpler ways. So we're going to use kubectls dry run and tell it, hey, can you give me a quick definition, a quick manifest for a pod that's going to run Nginx? I'm going to call it Kent to the dry cleaners, a reference to the movie Real Genius, which you absolutely have to see. So so we've written out that manifest. It says a YAML file, and we can take that file and just run this command one more time, or copy and paste and write it out to a pod file. And we're going to run kubectl create, and that's going to create our Kent to the dry cleaners pod. And now Kent's going to exec into this pod because that'll put him in the cluster instead of on his Mac laptop. He's also going to install JQ real quick because it's JSON query. As Carlos Vendramini at InGuardians has taught me, it's an incredibly useful tool for going through and both querying and changing JSON on the fly really easily. So Kent's first step is to go and talk to the cloud provider's metadata API, and because cloud instances will very, very often have service accounts, kind of like IAM accounts, and so he wants to see, those accounts in GCP. They'll often have read only, but read to every bucket, and that can be pretty cool. So he's going to go and basically query and find out what service accounts he's got. It looks like two, busted and default, but default is a symlink basically to busted. So he'll ask. We're going to do another query and basically ask the metadata API if we can have a token that we can use to authenticate to the Google Cloud services. So we just throw token, the default, and then a token on the end of that, and then we can take that and we're just going to parse it out with JQ. So we're going to toss that into JQ and get at that access token field. And so we get that access token field, we throw it through sed to pull off the quotation marks, and now we have something that we can put into a variable. We're going to call that variable token, and token is now that token. It's only going to, thing's only alive for 3,600 seconds. But during that time, it's useful to us. We could pull another one if we want to. We'll need the project ID as a number, not just as a name. But the metadata API will happily give that to us, at which point we can start doing authenticated requests. We're going to do an authenticated request against the storage API, where we're presenting a token as a bearer token. Storage API for bucket storage. We do our /b, which means I want to list all the buckets that are available in this project. And the first thing we get is basically something that says, nope, sorry, no good. This is basically a workload identity that's hitting us here, a GKE feature. A friend of mine, Aaron Small, helped ship. And this is making it so that we're not getting the nodes. Kent's not getting the nodes service account. He's getting one that's mapped to this specific workload, which is turning out to be useless. So we're going to have to try something else. And so now Kent's going to try something else. He's going to create another pod, and this pod, it's a little hard to follow with the word wraps, so we'll do it a second time. This pod is going to it's going to be the same kind of Nginx pod. He's going to call the pod privilege as a name, but use the same image. But we're gonna have the dry run kick this thing out as JSON, throw it into JQ, and have JQ set the specification for one of the pod's containers, and make that container have the security context privileged. And privileged pods, privileged containers, you should basically never have. You'll have it with a few of the control plane elements, but you really shouldn't have anybody else creating their own. So this is a JSON version of that manifest where security context has privilege set to true. And so we've written it out to a file called YAML, but it's JSON, and kubectl doesn't care. So we tell kubectl, here you go, stage this. It creates a pod called privileged, and Kent execs into it. And the first thing we see is this is what makes a privileged pod a privileged pod. It's among other things, we have all of these devices from the host, from the machine that this container is running on, published into the container. And that is no bueno for defenders. Luckily, our defender here is the Tooth Fairy, and we're trying to, fix things. So we've got one of those devices is DevSTA, the actual hard drive raw device from the virtual machine. So we do a quick fdisk just to see which partitions are which. Looks like SDA1's probably going to be really, really useful to us. And so we mount SDA1 into /mount. We root into there so that we basically, as we explore the file system in this shell, we're in the file system for the host, for that hard disk, not the file system for the container. And so I know I can find in home Kubernetes bin a copy of kubectl, which I'm going to want in here, or Kent's going to want. And so we'll find some other things, like take a quick look at OS release to see, yep, the container may have been Debian, but the host is Ubuntu. We can see the name of this. It's a GKE node that ends in that FJ9. We can see it's a Kubernetes, look at the message of the day, just kind of get a feel for, yep, this is a node. So let's look at something else that's really, really useful. It makes one of the ways that we can really, really make this attack count. There's a kubelet and there's a kube proxy, both of which on every node, and they both have their own cert to make requests against the API server. We're going to use the kubelets because the kubelet has to connect the API server to the container runtime, whether it's Docker, Containerd, or whatever. And it has to, the cool thing is that for any pods that are running on this machine, on this instance, this virtual machine, the kubelet is going to be the thing that's getting the secrets from the from the Kubernetes control plane and passing it into the containers. We're staging these containers with those, and so the kubelet will be able to read all the secrets for anything that's staged on itself, but not on other instances. So there's a kube config which refers to this PKI directory's client cert. If we look at that client cert, We find something we like, which is it's going to have not just a public key, but also private key. So this is going to let us authenticate to Kubernetes as the kubelets service, as the kubelets Kubernetes service account. And so we're just do a quick list, like get a list of all the pods. We see that, while there were tons of namespaces, the only three really in play are kubesystem with the control plane and developer Kent that we're playing with, and then this other thing, GPS, a reference to last year's holiday hackathon, which was impressive and fun as heck. And there are all these pods in GPS called logic bomb passwords. Remember, we're looking for the logic bombs passwords, so that's good for us. So we need to find ones that are staged on the same node, on this FJ9 node. And so we're going to grep for just FJ9, and these are the pods on the cluster that are staged to this one. And we see a bunch of control plane elements, but we also see 4 of those logic bomb passwords. And so let's go and look at the logic bomb passwords kind of status and definition to find out what their secrets are, so that we can go and request those secrets. So we'll take our kube control, continuing to use the kubelets cert. We'll get the pod definition for this specific pod. We'll ask for it in YAML. We forgot to enter the namespace. We add that namespace in, and we see there's a volume called logic bomb shutdown. It's provided. Its contents come straight from the secret called logic.bomb.shutdown, and they're passed in and placed on the file system in the etc directory. So what we're going to do is basically ask for a copy of that secret. And so if we, so just one more time, noting that that we're going for secrets that are only held by pods that are running on this node. That's really critical to understand. We're going to do our kubeconfig, ask for the secret. The first one just gives us the metadata for the secret. So if we ask for an output in JSON or YAML, we'll get the actual secret. And so we ask for it in JSON, realize we don't have JQ in here, we ask for it in YAML, and then we're going to grep out part 1, so we can just get that the data, and it is base64 encoded. So we're going to parse that, throw it into awk, try to toss it into base64, but there's a space, so we'll change the way we're using awk, and we get it. And here's our password. It says the first password is a line from Real Genius that Kent says, "You'll rue the day." But it says you'll need a second password. You got one flag, you got one more flag to go, and that's going to be found in a storage bucket, in a GCS storage bucket. So we know our next target is to get that storage bucket access. So it's time to try harder on that, on the GCS GCS attack path. So let's go and try something else. So Kent goes and basically says, okay, I'm going to try a different kind of thing. Instead of privileged, now I'm going to make my pod start with the host network set to true, which means it's going to, instead of starting its own network namespace, it's going to use the network namespace belonging to the virtual machine it's on, which can evade workload identity. And so we're going to stage that pod. Kent's going to exec into that pod, and now he's going to curl the metadata API. We see a different service account. This one looks like what we're used to when workload identity isn't in play. So he asks for an access token. I'm going to try to parse that out with JQ. Realize JQ is not there, so add JQ real quick. Since this is recorded, I was able to skip past that. And so we've got the access token. We're parsing it out with JQ and ripping off the double quotes, and that gives us what we need. So now we're going to set GCP token to that, and now we're going to construct our curl request to list buckets against that bucket storage API using a bearer token. Now, the first time I write this, I use token instead of GCP token, so we don't use the right bearer token, and we're not authorized. But I or Kent figures this out and uses the right bearer token, and here we go. We've got a list of storage buckets. There's only one bucket. It's called Tooth Fairy Second Password. That's a pretty good name. I have a lot of hope there. And now we're going to do B, then the bucket name, then O for objects. Give me a list of objects. And there's only one object. And that one object is a file called secondpassword.txt. And so we're going to you can take this nice little media link and paste it right in. So after our headers, we can throw in that media link, and we're going to get the file. And we got the contents of that file, the second password, which is, in the immortal words of Socrates, I drank what? So hey, thanks for watching. If you enjoyed this, please dig into Kubernetes and cloud native security some more. I'd love to talk Kubernetes with you here in the North Pole, or even collaborate with you on InGuardian's open source Kubernetes penetration testing tool, Paratis. Also, Kubernetes is cool in that there are a ton of people who are not just doing great work, but they're also eager to share it with others and help people get involved. I'd recommend following a number of notable Kubernetes security folks' work, and I've listed their Twitter handles here, but go looking also for their talks, their blog posts, their books, and their tools. By the way, the Kubernetes project has a new special interest group, SIG Security, and it's a really welcoming community looking for more hackers. So thanks a lot. I'll see you around KringleCon and the Holiday Hack Challenge. Bye-bye.
Ho, 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 ho.